Hi, so today's lesson is on section 6.1 if you're in my geometry class, but we're going to be talking about the angles of a polygon. Okay, so the angles of a polygon. So don't we really kind of need to know what a polygon is? It's got all these words. Well, the word poly means many, okay? So we know it's something with many. So a polygon is any two-dimensional shape, any two-dimensional, what's wrong with my pen today? Two-dimensional shape formed with straight lines. Formed with straight lines. Okay, so like a triangle, a quadrilateral, a hexagon, those are all types of polygon. In the name, the general forms, their name indicates the number of sides they have. But like a circle is not a polygon because it's not formed with straight lines. All right, and so then we have convex polygons. Those are polygons where all the vertex point outward. So like a triangle is a convex polygon. A quadrilateral is a convex polygon. A non-convex polygon is like where the vertex actually come inside the polygon. See how these straight lines being formed and it's kind of going on the inside of the polygon? We're going to be talking about in this class, we're going to be looking at only convex polygons, not non-convex polygons. Non-convex are also called concave. Okay, just so that you're aware of that. All right, so let's talk about this a little bit. Before we move on any further, I want to kind of do a little bit of an investigation. We're going to be talking about the sum of the interior angles of polygons. The sum of the interior angles of polygons. All right, well, we already know one. You know that the sum of the three interior angles of a triangle equals 180 degrees. We've been working on that for several weeks, and you feel pretty good that the three angles in a triangle, the interior angles of a triangle, add up to 180 degrees. All right, well, now let's talk about a quadrilateral. All right, so here's a quadrilateral. And, well, it's not 180 degrees because it's more than three angles. But we can use the idea of a triangle to see if we can figure out what the sum of the interior angles would be. All right, so I'm going to look at one vertex, and I'm actually going to draw a diagonal in the rectangle going across. Well, now I've actually created two triangles. Well, this triangle on the top, its angles add up to 180 degrees, and the triangle on the bottom, its angles add up to 180 degrees. So I can add them together. So the sum of the interior angles of a quadrilateral is actually 360 degrees. Okay, let's look at a pentagon. All right, so here's my pentagon. And I'm going to pick one vertex right here. And I'm going to draw those triangles again that I can find. Okay, so I can draw a triangle up here to this vertex. And I can draw a triangle here to this vertex. And I think that's it. So how many triangles do I have? All right, so I think you see three. So I've got 180, 180, and 180. Okay, and so 180 times 3 actually works out to be 540 degrees. All right, let's try one more, okay? And those are all true statements. A pentagon, the sum of its interior angles, 540 degrees. I'm going to try a hexagon, okay? Last one, hexagon, six-sided figure. 1, 2, 3, 4, 5, and 6. Okay, so let me switch colors. I'm going to take one vertex, this one, and I'm going to draw a triangle, and a triangle. All right, so that's 1, 2, 3, 4 triangles. So 4 times 180 degrees gives me 720. Okay, and this one I did 3 times 180 degrees, and it gave me 540. And this one I did 2 times 180 degrees, and it gave me 360. And this one I did 1 times 180 degrees, and it gave me 180. Well, the fact of the matter is, I don't want to have to do this every single time, do I? I don't want to have to sit and draw triangles inside figures to figure out their sum so that I can use it for something. So it'd be really helpful if we know the sum of the interior angles of any polygon. And what I'm hoping you're seeing is that if the triangle had 3 sides, and we multiplied 1 times 180, the quadrilateral had 4 sides, and we did 2 times 180. A pentagon had 5 sides, and we did 3 times 180, and a hexagon had 6 sides, yet we multiplied 4 times 180. So if I want to actually find, what you might be seeing is that the number being multiplied by 180 is 2 less than the number of sides. Look, 3 minus 2 gives me 1 times 180. 4 minus 2 gives me 2 times 180. 5 minus 2 gives me 3 times 180. And 6 minus 2 gave me 4 times 180. And that's actually how you find the sum of the interior angles. You take the number of sides, which is n. N refers to the number of sides times 180, and that will give you the sum of the interior angles of a polygon. Okay, so let's formalize this. So first I gave you a little chart, right? And I said the name, oops, let me give you a new page. The name, the number of sides, and the sum of the interior angles. Now, yes, helpful to know, but you can always use the formula if you need to. And so we're going to do that as well. All right, so name, triangle, 3 sides, 180 degrees. Quadrilateral. Quadrilateral has 4 sides. Quad means 4. The sum of the interior angles was 360. All right, pentagon. 5 sides, 540 degrees is the sum of the interior angles. All right, hexagon. 6 sides, and the sum of the interior angles is 720. And octagon has 8 sides, and the sum of the interior angles is 1080. All right, but what about a general number of sides? We call it an n-gon, an n-agon. That means it's like any random number of sides. So it has n sides, and so the formula would be n minus 2 times 180 degrees. So n minus 2 times 180. All right, and that's what we refer to as the polygon interior angle sum theorem. If n equals the number of sides of a polygon, then n minus 2 times 180 will give me okay. Sorry, my computer's doing funky things today. All right, so n minus 2 times 180 will give me the sum of the interior angles of a polygon. Remember, it's the sum. So you take the number of sides, you subtract 2, and you multiply by 180. All right, now remember that every polygon also has an exterior angle. The cool thing about this one, the exterior angles of a polygon, no matter how big the polygon is, the sum of the exterior angles will always be 360 degrees. And I'm going to show you that in class tomorrow why that is. But I want to demonstrate it. Okay, so how do we do this? It says, Here's an example. What is the sum of the interior angles of an octagon? All right, so we need to know that an octagon, octa means 8, so it's an 8-sided figure. So we're going to do n minus 2 times 180, and n is 8. So we do 8 minus 2 times 180, which is 6 times 180, which is, what is that, 1080? Now, you may remember that an octagon is already 1080, but that's how you do it otherwise. Okay, here's another example. A polygon has 24 sides. 24 sides. What is the sum of the interior angles? Okay, so n is 24. So we do 24 minus 2 times 180. So 22 times 180. All right, so 180 times 22. 2 times 0 is 0. 8 times 2 is 16. 2 times 1 is 2 plus 1 is 360. And same thing. So 360. So 0, 6, 9. So 3,960 degrees. The sum of the interior angles of a 24-sided polygon. What's the sum of the exterior angles? 360 degrees. It's really that simple. Okay. Now, how do we use this? Well, first of all, in example number 1 on the next page, you should have a right angle right here. So it wants us to find the value of x. So first we have to find the sum of the interior angles, just like we did for a triangle. And then we solve for the 4th angle, because this is a 4-sided figure. 1, 2, 3, 4. So we do n minus 2 times 180, which is 4 minus 2 times 180, which is 2 times 180, which is 360. Or just remember that a quadrilateral is 360 degrees. That's a really good one to know. All right, so then we add up the 3 sides we have. So 90 plus 50 plus 160 plus x has to equal 360 degrees. All right, so I'm going to combine the like terms. So 140 and 160 gives me 300 plus x equals 360, and then we subtract 300. So x equals 60 degrees. Make sense? So to solve for the missing angle, you take the whole sum and you subtract all the angles that you have to find the missing angle. All right, on the next page, or at the bottom of the page, you're going to see a question that says, what is the difference between a polygon and a regular polygon? Okay, this is a really important definition, so pay close attention. We're going to see lots of regular polygons. A regular polygon is a polygon, but it's still a polygon, that has all equal sides and all equal angles. It has all equal sides and all equal angles. Okay, so it's important because like an equilateral triangle, that is a regular polygon. 1, 2, 3, and all the angles are equal, and we know that all the angles are 60 degrees. How did we do that? Well, we take 180 and we divide it by 3. So we take the interior angles and we divide by the number of sides. A square is a regular polygon. So we take the sum of the interior angles of a quadrilateral, which is 360 degrees, and we divide it by 4, which is going to give me 90 degrees. Okay, so this is one way to do it. We can, if I have a regular polygon, it can only work if it's regular. It has 12 sides. It says find the measure of each interior angle. So we can do 12 minus 2 times 180. So 10 times 180. Oops, 180, not 108. And that gives me 1,800. Now we take 1,800 and we divide it by the number of sides, which is 12. So that's going to give me 150. So 150 degrees. A 12-sided polygon is going to have angle measures that are 150 degrees. Okay, that's one way of doing it. One thing I really want you to understand, though, is that actually make a picture. If I have a regular polygon, or actually any polygon, and I pick one vertex, like this. So there's one of the vertex. An interior angle and the corresponding exterior angle from that same vertex are always going to form a linear pair. Okay? So in a polygon, one interior and one exterior angle from the same vertex form a linear pair. This concept can actually help us find the number of sides. We can use the exterior angle anytime we want to find the number of sides. And here's an example. It says, find the measure of each interior angle of a regular octagon. All right, so I know that an octagon has 8 sides. So yes, I could do n minus 2 times 180 divided by 8. Or I could do 360 divided by 8 to get each exterior angle. Okay? So 360 divided by 8, I'm going to do the work over here. 8 goes into 360. 8 goes into it 4 times, and you get 32 and 40, so 45 degrees. So that means there's 45 degrees in an exterior angle. And we just said that an exterior angle is a linear pair with the interior angle. So we can just do 180 minus 45 and get 135. Okay? Or we can do 8 minus 2 times 180, which is 6 times 180, which is 1080, and then do 1080 divided by 8, which gives me 135 as well. So multiple ways of doing this. I like to use the exterior angle just because I don't have to remember anything other than 360 divided by the number of sides. All right, so here's a question. A regular polygon has 12 sides. Find the measure of each exterior angle. All right, so we have to use the exterior angle theorem here. So we do 360 divided by 12, and we get 30 degrees. Okay, 30 degrees. So each exterior angle is 30 degrees. All right, so let's go through the table based on each piece that we get. Okay, if we have 6 sides, it says find the measure of each exterior angle. All right, so I'm going to do 360 divided by 6. It gives me 60 degrees. So each exterior angle of a 6-sided figure has an exterior angle of 60 degrees. Because it's regular and because I want the interior angle, I just do linear pair. So 180 minus 60 gives me 120 degrees. All right, let's try it again. I have a 10-sided figure. So I do 360 divided by 10. That gives me 36. That's the exterior angle. Remember, these are exterior angles, interior angles. So each exterior angle is 36 degrees. To find the measure of each interior angle, I do its linear pair. So 180 minus 36, which gives me, what is that, 144? Okay. You try 20, bring it to class, and we'll check. All right. Working backwards. Now I have each exterior angle. I want to find the number of sides. Well, first I'm going to find each interior angle. So I know they're linear pairs. So I'm going to do 180 minus 10, which gives me 170. Okay, so to find the number of sides, you do 360 divided by the angle. It will give you the number of sides. It's the same exact thing as dividing by the number of sides to give you the angle. So 360 divided by 10 is going to give me 36. okay? So 36 sides. All right, let's try the next one. The measure of each interior exterior angle is 20. That makes each interior angle 160 degrees. To find the number of sides, we're going to do 360 divided by 20. So I'm going to cross out the 2's, and 36 divided by 2 is 18. So it's an 18-sided figure. All right, remember, just work with those exterior angles. It's so much easier. All right, 179 is the interior angle. I'm going to then find the exterior angle, which is 1. I'm going to do 360 divided by 1, which gives me 360. So this has 360 sides. All right, the next one, the measure of each interior angle is 90. I'm going to find the exterior angle, which is also 90 because they have to form 180. And then I'm going to do 360 divided by 90, which gives me 4. So a 4-sided figure. Okay, guys, so hopefully you understand. I want you to make sure that now after this video, you know what a polygon is, and you know the difference between a polygon and a regular polygon. You should be able to tell me how you find the sum of the interior angles of a polygon. You should be able to tell me how you find the sum of the exterior angles. You should be able to tell me that an interior and an exterior angle from the same vertex form a linear pair. And you should be able to find each angle in a regular polygon, both interior and exterior. And also be able to work backwards to find the number of sides. Okay. So I know it was a little bit longer today. I appreciate your patience, and I will see you mañana.